Hello, everyone, and welcome to today's meetup session. Thank you all for joining. Just for a bit of admin and housekeeping purposes, the session is being recorded and it will be available on our YouTube channel. It will be uploaded this week. We will be saving 10 minutes at the end of the presentation to go through questions and any talking points that people may have. So please keep your questions on hand, and then if you would prefer at the end of the session, you can drop them in the chat. Today's session, we will be looking at EcosystemCode, and the product lead for EcosystemCode, Christina, is going to be leading today's discussion overview as well. So with that said, I am going to hand over to her and she can kick it off. Thank you.
Thanks, Maddie, and thank you everyone for joining. This is another one of our EcosystemCode sessions, which is very, very exciting because we do have a plan throughout the year, and it's great to kind of have the ball rolling already. And today, we are going to be discussing the basics and I think the core functionality behind building reliable AI code bases. And we're going to be leaning quite heavily on model context protocol. We'll discuss in depth what that means, the intelligence behind it, and how we can best equip ourselves when we are using EcosystemCode as a platform to work on those things. Before we jump into that, one quick thing: if you found this on Meetup or you're not on our Discord, please go ahead and scan the QR code for our Discord community. This is where the conversation will continue after today, and we look forward to sharing resources from every session. We have a channel specifically to any problems, any of the things that you're building, and to also grow the community in this space and to address any concerns. It's free, it's active, and if today specifically resonates with you, we'd love to hear your thoughts on the platform as well as we build and we develop going forward. Okay, perfect. So jumping into today, we've got quite a jam-packed agenda, and I'm very excited to discuss so many of these things. If basically you are someone who's already using AI to write your code, or AI in various aspects, right? Whether these are platforms like Cursor or Copilot or Claude Code or anything else, really, you really understand what it means to ship fast, right? Especially early on in a project. And a lot of you have also felt the other thing. And sometimes, usually when you're a few sprints in, when you've gotten your flow, something starts to feel off, right? Things start misbehaving and things break, and there isn't quite an explanation. And I think one thing we want to establish here today is not to replace that system, not to replace your process to development, but to provide that architectural understanding to better equip you going forward. And that's what we're going to talk about today. We've got a name for it. We've got a precise explanation for why this happens. And this is the part that I think will be useful for all of you today. A fundamentally different way of approaching AI-assisted development that closes that gap at the root cause rather than patching it after. If we can address such things before we even go far, I think it would be definitely beneficial. So with that being said, we are starting with the problem, and that is architectural entropy. Why does AI-assisted development feel fast and then suddenly it doesn't? And the specific mechanisms behind that. If you've experienced what is known as the regeneration trap, this section will definitely dive into that and also to provide an explanation. Therefore, we will move more into the solution layer. We'll cover model context protocol, which is the open standard that makes structural context delivery to AI models possible. And this is the infrastructure underneath everything we're going to show you today. And it's worth understanding properly rather than taking it as a given. Thirdly, we'll establish the role that EcosystemCode plays in creating a space and a platform for this. Specifically, what it does differently, why the concept of what I'd like to call pre-computing your architectural context changes what the AI is actually working from when it generates. Then from there, we go deep on the engineering side, right? We'll look at design engineering. How do UML diagrams become live constraints on AI generation rather than documentation that no one reads? From then on, we'll move on to the deterministic spine, right? So how do these layers stack or connect to each other to create a single structural reference? And this is where we want to be mostly. You will definitely, I think, find this quite interesting. After this, we'll be covering the interpretability and traceability of this all. And this is essentially what it means for a code base to be fully legible when every generated component has a visible architectural origin, right? Then real world deployment, where we look at how this plays out specifically, whether that's in a specific job can be identified. Therefore, after that, we will then close with a synthesis where we pull together all these arguments and to leave you with a clear architecture of what AI-first architecture development actually looks like in practice, to equip you better when you're generating those user stories, when you're faced with a challenge in your current job or in your workplace or something that you'd like to experiment on. You can approach it from that understanding of how ecosystem code works and how it is built to deliver the best outcome for you. Perfect. First things first, the entropy of code. And for this, I want to start with the problem most of us have probably felt, but we haven't had a name for this. And this could be where you've been building something with an AI coding tool, whether this is Cursor, Copilot, or maybe directly with Claude. And early on, it is absolutely incredible. It does everything you need. It's moving fast. The features are coming together in hours, previously where it used to take days. But then after some time, things start to drift, right? Where we see the auth layer behaves differently depending on which session you generated in. You can have two engineers that are working on adjacent services that have somehow come to build different interpretations on the same model, right? Your API docs tend to describe endpoints that don't quite match the actual implementation anymore. And you come to understand that it's not because anyone made the wrong decision. It's just that the AI made a slightly different decision every single time it was prompted, right? And this is what we call architectural entropy. It's not a bug, but it's a fundamental characteristic of how large language model works. Every generation is a fresh probabilistic inference. There is no memory unless you explicitly provide it. It's just going to go off of what you tell it there without a persistent structural reference, something that says this is the canonical shape of this system. Every drifts little by little, and over time, those drifts compound. And so the term vibe coding captures this pattern perfectly. You're iterating fast, you're prompting intuitively, you're getting outputs that look and feel great, but you're not building against a fixed architectural contract. You're building against the AI's best guesses at what you probably want. And so what we see is the regeneration trap happen when you try to fix this later. You go back to refactor a service and the AI produces something structurally different from what was there before. It's not exactly wrong, but it is different. Now you have a code base that's half one architectural dialect and half another, and then reconciling these costs more than starting over. And this is the problem that we are going to address. How do we address this in a way that equips the person that's prompting the system with the toolkit to understand and to bring engineering back to what is known as vibe coding? So how is this then embedded within ecosystem code? Ecosystem code basically addresses the architectural entropy at the root cause. It doesn't do this by improving prompts, but it eliminates the reliance on prompts as the sole carrier of architectural intent. So the platform captures architectural decisions as structured blueprints. We see this through class diagrams, your service boundaries, your API contracts, your infrastructure topology, and holds them as persistent source of truth across all interactions on the platform. So when a developer triggers code generation inside ecosystem code, the AI does not receive a blank slate prompt. It receives the current architectural slate of the relevant component surfaced through model context protocol before generating absolutely anything. The intuitive, fast-moving development experience is preserved over time, but the outputs are anchored to a fixed architectural reference rather than a fresh probabilistic. And through this, we see that the regeneration trap, is broken because regenerating any component always starts from the same blueprint. The AI's output is deterministically constrained by the structural context. And so what we see from this is that AI development is not the problem. The problem here is unanchored AI development, right? Where we see the regeneration trap closes the moment every generation begins with structural context rather than an open-ended prompt. So from the problem to the protocol. So we've come to see that model context protocol can be viewed as this mechanism that makes structured context delivery possible. And so in order for us to do that, let's understand what it actually is and why it changes everything. So before we talk about how ecosystem code uses model context protocol, let's make sure that we all have a clear picture of what it actually is, because there's a lot of noise around this nowadays, right? from our understanding since its launch, it is basically an open standard. And this was published by Anthropic that defines how AI models communicate with external systems. Think of it as the USB-C of AI integration. Before USB-C existed, every device had its own connector. You needed a different cable for absolutely everything. After USB-C, however, there became one standard connector that works everywhere. And so MCP does the same thing for AI. Instead of every tool building its own bespoke integration with every model, MCP defines a single communication standard that any model and any tool can implement. And so because of that, the architecture is pretty much straightforward. You have a host, which becomes the AI client, and you have a client, which becomes the protocol layer that manages this connection. And you have one or more MCP servers, the systems that expose structured context back to the AI. The MCP server bridges your code base, your diagrams, your architecture and tools, making them queryable. You can question them, you can go back to try and understand how everything was constructed for the AI model. And so the key word here is structure. This is what makes MCP fundamentally different from putting things in a prompt. Prompt context is this sort of blob of text. The AI has to interpret it and make assumptions about what's authoritative. So MCP context arrives as structured, right? It is typed, it is purposeful information. And so through this, the AI then knows exactly what it's receiving and also how to use it. So then from this is that the result is not just better outputs, it's consistency across sessions. So every time generation is triggered, the same MCP server provides the same architectural context, right? This is where the AI actually works from the same source of truth, regardless of which session, regardless of which developer. And this is pretty useful when you're in a team or an organizational context. Now, when Anthropic published a research paper on model context protocol in November 2024, within 3 months, this protocol had been adopted by software development platforms far and wide. And this signaled to us a rapid ecosystem momentum around the standards. So the core design behind MCP, which is structured context over unstructured prompts, aligns with research showing constraint generation produces more accurate and consistent output. And this is pretty much beneficial in the day and time we live in. And a key architectural advantage of MCP over function calling alone is its server-based persistent model. So the MCP server maintains state about available resources and tools across the session, enabling multi-step architectural reasoning without context window bloat. And so we asked then, how is this embedded within EcosystemCode? So EcosystemCode ships with a built-in server that exposes the platform's architectural knowledge graph to any compatible AI model, right? It surfaces 4 resource categories. Number 1, the architectural blueprints. Through these, you have the UML diagrams, the domain models. Secondly, you have system resources, right? You have your existing code base, you have your API specs, you have your infrastructure configurations. Thirdly, you have tools and resources, right? These things such as your database schemas, your external APIs, and your auth providers. And lastly, what we see is persistent context, architectural decisions, design rationale that is consistent over time and can be traced as well. So progressive disclosure is built into the MCP layer. So this means that when a developer generates an API endpoint, only the relevant API design surface, and so not the entire architectural graph. And this keeps the AI context window clean, precise, and quite efficient. So MCP integration is model agnostic. So we see that in teams such as Claude and GPT as well, and any other MCP compatible model that get the same structured context delivery. EcosystemCode's value is in the architectural layer. And so it's not being tied to any specific model. And so those that are building full stack apps on the platform do not configure or interact with the MCP server directly. It operates transparently in the background. So every code generation action automatically triggers the appropriate MCP context before the AI even receives the request. So from all of this, we can see that MCP transforms the AI from a stateless text generator into this context-aware architectural collaborator. The protocol is the bridge between the human-defined architecture and the machine-generated code. So now we know what MCP is. And so now we want to see, how does EcosystemCode use it? And why does this architecture-first approach enable such a step change that is different from anything that's available on the market today? So I think in that case, positioning really matters, right? EcosystemCode is not an IDE. It doesn't replace your terminal. It doesn't replace your debugger. Instead, it sits above that layer, at the architectural layer. This distinction matters because the problem that we identified previously is not a code editing problem. It's an architectural coherence problem. So you can't solve a structural problem with a better text editor, for example. You need a tool that operates at the right level of abstraction. And for AI-assisted development, that level is architecture. And so here's the core workflow, right? You have traditional AI-assisted development where you have an idea, you write the prompt, the AI generates the code. Architecture, on the other hand, if it exists at all, is described loosely in the prompt or lives somewhere that no one ever looks at. And so the AI is guessing at the intended structure, compared to the ecosystem code workflow where you define the feature architecturally, right? So what services does it touch? What data does it need? What does it expose? Ecosystem code assembles that as a structured MCP context. The AI generates against that context, and then the code emerges from that architecture and not simply from a prompt. So through this, then, we have a question that we need to sit with for a moment. When AI generates your code, what is it actually starting from? Is it starting from a prompt? Maybe a good one, maybe one with a lot of context that's carefully packed, but it is still a prompt, which means that the AI arrives at a generation code. It has simultaneously had to infer your intent. It has to reconstruct your system structure, guess at your architectural constraints, and then produce code. So then the question that we then further ask is, what if that structure was already done before the AI received the request? What if instead of asking the AI to figure out your architecture mid-generation, you handed it a pre-solved picture of exactly which services are involved, which boundaries apply, which entities exist, which communication patterns are in force, assembled, structured, and ready before it wrote a single code? And that's what EcosystemCode does, right? It pre-computes your architectural context. So not the code only, not just the structural foundation the code needs to be correct. So that by the time an AI, regardless of which one that you use, generates, and you have this sense of ambiguous work of contextual assembly that has already happened at the MCP layer. And because of that, the AI then is not just guessing your system, it's reading a prepared answer about it. So we have to think about databases rather in a way that uses indexes. So without an index, every query scans the full table and reconstructs the answer from scratch. However, with an index, the relevant data is pre-organized and the query just reads the result. And so EcosystemCode does the same thing for AI generation, except that the index is your architecture and the code is every code generation task that you run. So from there, I think it's important that we dive a bit deeper into the design engineering side of things, right? To specifically understand how UML diagrams become the structural guardrails that make AI generation precise and reliable. So what we've come to see is that in a lot of organizations, UML became synonymous with documentation. It's one thing that you kind of think of as part of your day-to-day work that you don't want to engage with, as these heavyweight diagrams that are produced by architects and that are ignored by the engineers. But that's a legitimate criticism of UML, right? That it tends to feel like something that you cannot see a tangible outcome for. But the value UML was never in the diagrams themselves. It was more so in the structured, machine-readable representation of system behavior that the diagrams encode. So in the context of AI-assisted development, that value has become dramatically more important because now the machine that reads your system structure is also the AI generating your code. So structured diagrams are precisely what the AI needs to generate correctly. We see this, for example, through class diagrams, right? They define your model, the entities, the attributes, the relationships that constitute your system's core data structure. So when this is captured in a class diagram and it is exposed via MCP, the AI cannot invent fields that don't exist. It cannot misrepresent cardinalities, and it cannot generate foreign keys that violate the intended relationship structure. And so you have something that is not guessing at your data model, but more so that it's reading it. Another case that we have are sequence diagrams. These define temporal behavior, which services to call for in what order, with what data at each step. And so this is where AI hallucination most commonly produces architectural violations. And without context, an AI might generate a direct call between two services that should communicate through an event. And so what a sequence diagram does is that it makes that constraint explicit. MCP surfaces it at generation so that the AI knows what it should be doing, right? It knows the call should be asynchronous before writing a single line of code. And so we see this within EcosystemCode as it provides a built-in diagram editor for all four UML types with validation rules that enforce that structural consistency between diagrams. For example, every class referenced in a sequence diagram must exist in the class diagram, right? Class diagrams also bidirectionally linked to the database layer. So changes to entity relationships automatically flag downship generation tasks as requiring regeneration. So all these diagrams are linked to the features that depend on them. And a change to a class diagram shows which API endpoints, service methods, and for example, infrastructure components are affected any code is generated. And so what we see from this is that within EcosystemCode, every diagram is a live constraint on AI generation, eliminating hallucinated services, relationships, and infrastructure from the output before a single line of code is reviewed. Now, let's see how these diagrams types connect into a single deterministic spine that proves governance generation across every layer of the system. So we've talked about each individual diagram. Now, I want to show you, or discuss rather, how they connect. Think of your system as a building, right? And the system consists of class diagrams, sequence diagrams, state diagrams, and for example, component diagrams. If any one of these is isolated from others, you get a building with plumbing that doesn't connect to the rooms, load-bearing walls that cut across the floor plan, and a foundation that doesn't quite match the footprint. And this is exactly what happens when AI generates, rather, individual system layers without a shared structural reference. So the deterministic spine is the connected architectural layer that ties all 6 engineering domains together: your foundations, your API design, your database, your big data, and infrastructure. When these are defined in EcosystemCode and connected through their structural relationships, the AI then has a complete, coherent view of the system at every level of abstraction. Now, with that, I think it's particularly important to note that progressive disclosure is the mechanism that keeps this manageable. You don't want the AI receiving the entire architectural graph every time it generates a function. Instead, EcosystemCode's MCP server determines which portion of the deterministic spine is relevant to the specific generation task and surfaces only that. Generating an AI API controller, for example, so you get the API design context and the relevant sequence diagram. There's a plethora of research in this space that covers the concepts of a single source of architectural truth that maps directly to the principle of integrity in a database design. So how is this embedded into the core functionality of EcosystemCode? The deterministic spine is represented at a connected knowledge graph where each node, as you would analyze in your diagram, is an architectural artifact, whether this is a schema, a spec, or an infrastructure configuration. And each edge represents a dependency or derivation relationship between these artifacts. And then from there, what I think it really entices me from time to time about the deterministic spine is that it does not constrain what you can build. Instead, it defines the boundaries within which the AI builds reliably. Every generation is coherent because every generation begins from the same structural truth. And this is something that is missing at the current stage, but is it missing going further? I think ecosystem code is precisely the platform for that. And I think the accessibility of it provides the perfect opportunity to experiment in that case. With that being said, I think it's important that we look at the interpretability and the traceability of when your entire system is built on a structural foundation like this, and what the implications of this are. So with a standard AI-assisted development, there's a real interpretability problem. And this means that code gets generated quickly, it works, it gets merged. But why was it structured that way? Why does this service call that one? Why does this entity have this field? And the answer is often because that is what the AI produced. And if that answer isn't good enough for your team, for your engineering leads, then you have a problem. Architectural traceability means that every generated component has a visible origin. The API endpoint exists because the sequence diagram specified this interaction. The field exists because the class diagram defined this entity, right? The network rule exists because the deploy diagram declared this boundary. So every architectural decision has a documented source. And this is not just good for audits, it's transformative for onboarding. If a new engineer joins a team that uses ecosystem code, allows them to look at any service and trace every component back to the architectural decision that produced it. In the past, this could typically take about a week, and it is quite time consuming and has effects on productivity. However, on an architecture-first code base, this can take minutes. So the feature context within ecosystem code is the mechanism that enables this, right? It is a live representation of the relationships between every feature, each service, each API, each data entity, and infrastructure component in your system. You can ask it what depends on the service, and you can get a clear answer. You are able to analyze and see that if I break this, will it change this schema, and therefore see the full impact before you even touched a line of code. And so this traceability is not just a nice to have or a by the way. I think it's particularly important, especially in the fast-paced times that we live in. If we're thinking about productivity, if we're thinking about deploying things at scale as well, right? This byproduct of architecture-first development is more imperative than ever before. So before any architectural change happens, developers can run an impact query, right? That allows them to see and analyze this even more. We like to call architectural provenance. And this is where every generated code artifact carries metadata that links it to the blueprint and the MCP context that was assembled before its generation. And I think that's particularly insightful. So from this, we can see that architectural traceability transforms AI-generated code bases from these black boxes, from these boxes that lack so much understanding because they're so complex, into fully legible system where every decision has a visible origin and every change has a predictable scope. Every audit has an automated answer. So let us make this a bit more concrete and to understand better how this plays out in real world context, right? So everything we've discussed so far has been more on the functionalities of a platform before it lands in a real team, in a real organization, in a real system with real constraints. And I want us to look at these 4 industry context. For example, if we take enterprise platforms, these tend to be large organizations that run complex internal platforms that face a different version of the same problem. And that is scale, right? This is where you have dozens of teams, hundreds of services, and architectural drift that is accumulating across every team boundary. Ecosystem code addresses this through shared blueprints, which is an architectural reference that every team generates from, regardless of who produced it. This structural consistency at an organizational scale provides that centralized enforcement. In product engineering teams, for example, we have pretty big problems. And one of those is tenant isolation, right? Where we have patterns that need to be consistent across every service and every endpoint. So what EcosystemCode does is that these patterns are declared at the blueprint layer through the UML diagrams, and they are applied consistently by the AI across every generated component. We also have big data, and we see this in data engineering teams that define complex pipelines with precise requirements about how data should move, about transformation sequences, about schema evolution. The difference between a correct and an incorrect pipeline can be a silent data loss or a downstream model trained on corrupted inputs. So what EcosystemCode's pipeline architectural layer does is that it captures the intended data flow as a structured blueprint. So the AI generates producers, consumers, and transformers that respect this intended flow, and it doesn't just adopt a generic template. And one point I want to emphasize, as much as the platform has these different functionalities, it only ever exposes structural metadata to the AI models that we use. So things like credentials or proprietary business logic or sensitive configuration, they never enter the context window. The architectural layer and the data layer are deliberately separated. And so through that, we can see that at an enterprise level, EcosystemCode supports organizational blueprint libraries through shared architectural references that multiple teams can extend without modifying the base. Platform teams can then jump on and define the standards, and product teams can generate from that. And we have a space to track this divergence. For product engineering, we have multi-tenancy patterns that have feature flagging architectures that operate at a first-class blueprint component level, right? Where developers can then track these patterns through their blueprints. And the AI, or rather the platform, applies them consistently in all its generated code. Lastly is the big data, and I think it's one of the most exciting things to see, especially throughout this year, in understanding how each stage can sort of declare this through its schemas, its inputs, and its outputs, and also the transformation logic, right? To be able to understand and digress how the AI generates these stage-specific code that represents upstream contracts. So we see that architecture-first development is not just a quality practice. It's rather something that is necessary governance mechanisms. And EcosystemCode makes this possible and an emergent property of good architecture rather than just a random manual review step that pops up from time to time. So I want to bring this all together and to understand what this means for the teams that we work in, for the code bases that we work with, and just development as a practice going forward. Okay, and for that, we have to return to the problem that we started with. And we need to understand that vibe coding is not the problem here. The speed, the intuition, the creative momentum of AI-assisted development, that's something that I strongly feel is genuinely valuable, and it's not going away anytime soon. However, the problem with vibe coding is that without an architectural anchor, the problem is velocity without structure. We're building so many things, but we're unable to go back and assess the systems that came together to establish what we find. And what we've built in and with EcosystemCode is exactly that anchor. It's not a set of restrictions on what can be generated. It's not a gate that slows down development, but rather it's an architectural layer that the AI can generate from, so that every output, whether it's an endpoint, whether it's a schema, whether this is an infrastructure resource, is a derivation of an explicit structural. So let me summarize what this looks like in practice. You go into EcosystemCode, you define the features architecturally once, right? The deterministic spine connects these definitions across every layer of the stack. The MCP server surfaces the right slice of that spine at every generation step. The platform then produces code that is coherent, that is traceable, and most critically, is something that you can regenerate, not just once, but whenever. Even 6 months from now, when you need to rebuild a service, or if you need to migrate something new into the features, or onboard a new team member who needs to understand the system that you work with in your organization, the architectural truth is there, living in ecosystem code. And so these outcomes that we've discussed so far allow your system to remain coherent, because generation always begins from structure. Your architecture stays stable because the changes flow from the blueprint layer downward and not necessarily from the individual sessions upward. Your code base becomes auditable because every generated component carries architectural provenance, and regeneration becomes repeatable because the deterministic spine is the constant across every session. So every team that's using AI to generate code is making a choice about where architecture sits in the process. Some teams let architecture emerge from the code that is produced, which means that it's always slightly different from what was intended, and it's always slightly inconsistent between components. Other teams define architecture first, and they let the AI generate from it. Every session produces outputs that are coherent with each other and the team's actual intent. So the approach that produces fast code bases that are increasingly difficult to maintain is something that needs to be reconsidered, compared to code bases that are produced fast but have that sense of reliability. And that's what ecosystem code is built on. And it is designed for this incremental adoption where teams can start with a single service, define the blueprint, and connect it to their AI workflow. So the value becomes immediate, right? One architecturally grounded generation task demonstrates the difference, where teams then can expand coverage service by service. And these architectural blueprints sync with your existing repositories, and generated code is delivered directly to your workflow. And so we see that the tools that make AI development fast and widely available are these. This is what we need. And so the missing capability has always been architectural grounding, not just the problems that come from AI developed code, but more so the understanding of it. We look at vibe coding and see it as something that people that don't know how to engineer, people that don't know use, but it can be something that has elements of engineering in it. If you're able to understand how different elements work, how they're all connected, this could bring back that engineering aspect to it, and also the power that comes with working with AI to affect your productivity and also just affect and impact how work is done in a day-to-day. Thank you. If you have any questions, I'm happy to answer them. And yeah, looking forward to engaging with you guys.
So there are some comments and questions in the chat from Michael. I am happy to read them out.
Yes.
So the first one is, a buzz phrase that I'm seeing more of is ontology-driven architecture. And the question is, how is the ontology context provided to the model via MCP?
Could you repeat that again, Maddie? Sorry.
Sure. It is, how is the ontology context provided to the model via MCP? Maybe, Michael, if you'd like to elaborate a bit more. And I think Jay is on the call if this is something he's also familiar with and would like to help answer.
Yeah, Madison, can you hear me?
Yes, we can. Thank you.
Yeah, so I'm seeing this cropping up quite often. I can see Jay is ready to jump in, but just to kind of provide an example, one of the famous ontologies is the good old wine ontology with grapes and types of wine and regions and meals and food pairings and so on and so forth. So if you're building an application for culinary organizations or in any organization producing food, you're trying to provide that kind of context during the development of the application. So yeah, so that's kind of like the business or the informational context that underpins the application that you build for the wineries or the restaurants or whoever's using that information.
And Michael, the thinking is that what we want to do over time is support a hierarchy of ontologies so that you can pick, let's say you take the financial industry business ontology, so it understands what an account and a legal entity and a relationship is. And the challenge is so far for us that if I take, let's say, a financial services example, is that the language that is used in different regions are different. So that means you would need ontologies from all over the world. So what we did was we shifted the thinking into domain-based design. So domain-based design is that if you can initially drive a certain set of assertions based on the industry that you're in, you can still generate the first version of the outcome, whatever the system is that you want to create. So if you say to it that you take a horizontal discipline, like let's say CRM, that has got a pretty well-defined understanding of an ontology, and if you then give it a product hook and you say to it, use customer relationship management Salesforce style, or use customer relationship management using Sugar CRM format or whatever it might be, it will take that product's language and it will extract the ontology from that discipline. As soon as you go vertical, there is a dual track part of this product. One that is the public edition, where the ontology is only at the moment extracted from the domain that you provide in the description of the prompt. So if you say to the prompt, let's take the example, you said now like a restaurant, and I know that wine in this context means something that I can drink. It's not something that somebody says. Well, if I talk about a jaguar in the context of a zoo, it means something different than jaguar in the context of a car company. So the idea is that you know the problem, how we describe it. So the idea would be over time that there's a standard for providing an ontology in the template set. So the tests that we've been running, that have been hundreds of tests, have mostly been around horizontal disciplines where the definitions of how the language is used in those definitions are pretty well understood. So it is definitely an ongoing focus of research for us to make that in the enterprise track. Like in the enterprise track, if you take what happened in, let's say, the telco space, or if you look at open banking, the ontology around the open banking language, that is mostly a British-based definition or description, is very difficult to apply that in a US context. But you can apply it in, let's say, an African or Southeast Asia context. So we are working on trying to find the best approach to get the definitions and the language for what you're going to be generating consistent.
Thank you for that, Jay. I see there was a question regarding recordings, which I have answered. This will be posted on our YouTube. Are there any other questions, comments, or thoughts? Any last few notes, Christina, that you'd like to share? Michael, go for it.
Thanks, Madison. There was one other quick question about architectural decision records. So they popped up in one of the slides by Christina. So in essence, trying to formalize those decisions, you've actually got kind of formal records that are kind of time-stamped. You've got an indication whether they kind of went to some kind of architecture review board and whether they were approved by a human. So just kind of tightening up that step where the architecture at an enterprise level is kind of more formalized and the decisions are kind of more formalized. And presumably some kind of open standard around some kind of ADR system. I know from interactions with Sunlum in the past, I don't know if anyone from Sunlum is on the call, a lot of the architectural decision records were put into Confluence. It wasn't a formalized database as far as I could make out. If it was a formalized database with kind of different architectural contexts and kind of almost like an architectural ontology, it would be useful to revisit a lot of the architectural decisions and be able to find them quite quickly and easily. So yeah, I don't know whether you've given any thought to that side of things.
Yeah, definitely. And we don't get involved. So we don't get involved in the internal decisioning of a company because the approach that every organization will follow will be quite different. And the way that they would describe, once they've created, let's say, an enterprise style project, you want to split up, let's say, the back end into 2 or 3 layers or whatever it might be. We will support it to a certain extent. The way that we're looking at it at the moment, in the context of the product line practice approach, is that the data layer is fundamentally different from the back-end layer, from the front-end layer. There is no messaging layer at the moment that is supported out of the box that we're working on. So that will by default generate that for you. By the time let's say you use the public edition, that will use a standard multi-tier architecture that you can push straight into the cloud or onto your local infrastructure. If you use the enterprise version and you buy access to a project from us, then it could be any architectural definition, and then you will follow whatever practice the company has internally. And Michael, so that means that what you normally would do is you will create a snapshot. There's a versioning tool that you would version your project. And every time you have a version, you could obviously, like normal things, give it a name or whatever it might be. And that should then map onto whatever practice you have inside the business. It's a bit like, Confluence is not responsible for your architecture, they're only responsible for you documenting it there, or for you to, well, not even documenting it, for you describing it there. That is exactly the same challenge we sit with. So we very much focused on the content that gets generated rather than all of the practices that might be accessible. So that's why things like teaming and versioning and so on are flexible enough for people to fit it within their practice. And in the enterprise setting, what we found is that if you're going to create multiple waves, and let's say you have a self-correcting, AI tool, and a self-correcting deals with a generative component and a deterministic component. The current architectural practices focus almost entirely on human, where in the practices we're moving into is that you want to separate your deterministic feedback from your generative feedback, because the one you've already set the rules. That's where you normally would apply your ontology or your architectural standards, or you'll at least have a common taxonomy of definitions. Where in the generative component is where the risk lies. How much leeway do you allow the pure generative component to play out? And that is what you need to be very careful of. And there the practice fits very similar, or fits into the base of how you would run Cursor or Windsurf or any one of those sort of tools that are currently in that kind of space. So I think the AI tooling world, the way I'm looking at it, even if you think of, looking at Microsoft tools or Google's tools or, any of those, even Amazon's AWS tools online, the versioning, the practice, the decisioning is an external factor. So we follow that exact same practice. Yeah. It is, but I mean, like any of these things, how it goes, they all evolve based on what feedback looks like from real humans or real people using it. So, and that's why, Christina's got an explanation. Thanks. It was awesome.